March 23, 1945, western bank of the Rhine. German engineers had calculated it would take the Allies weeks to build bridges under fire across the icy current. They watched American troops massing equipment along the riverbank, counting pontoons, measuring timber. Standard crossing doctrine, predictable, containable. Then trucks started driving straight into the water. Not sinking, not stopping, navigating the Rhine like it was just another muddy road. The Wehrmacht had spent months perfecting river defense tactics, positioning artillery to shred any bridge construction, timing counterattacks to hit vulnerable crossing points. They never planned for vehicles that turned water into a highway. Stay to hear the intercepted phrase that made German observers question their own eyes. Last Wagen auf dem Wasser. The Rhine had been Germany's natural fortress for centuries. 400 meters of fast-moving current, too wide for most military bridges, too deep for fording. By early 1945, it represented the last major barrier protecting Germany's industrial heartland. More than 20 German divisions stretched along its eastern bank, dug into positions that had been months in the making. Wehrmacht defensive doctrine was precise. Let the enemy exhaust themselves building bridges. Hit the construction crews with artillery. When they finally establish a foothold, crush it with concentrated counterattack before supplies can flow. The math favored defenders. Every ton of ammunition, every gallon of fuel, every replacement soldier had to cross a choke point under German guns. At least that was the plan. American supply officers had been wrestling with the same equation. Operation Plunder would put multiple divisions across the Rhine simultaneously, but sustaining them meant moving massive tonnage across contested water. Conventional bridging operations would create obvious targets. Ferries were too slow. Air supply couldn't handle the volume. That's when someone remembered the amphibious trucks gathering dust in Pacific Theater surplus warehouses. The DUKW, officially General Motors DUKW 353, nicknamed Duck, had been born from a 1942 conversation between a yacht designer and a truck engineer. Take a standard GMC 2.5-ton truck, add a watertight hull, install a propeller, keep its wheels. The result looked like an engineering compromise, but it solved an impossible problem: how to move cargo directly from ship to shore without docks, cranes, or lengthy unloading procedures. Pacific Island campaigns had proven the concept. DUKWs could haul artillery pieces across coral lagoons, carry wounded soldiers from beachheads to hospital ships, supply forward positions that conventional trucks couldn't reach. At Tarawa, DUKWs had navigated shallow reefs that stopped conventional landing craft. At Iwo Jima, they supplied Marines pinned on black sand beaches. At Okinawa, they evacuated wounded under enemy fire, their dual nature allowing seamless transition from water ambulance to road transport. But the Pacific was warm water, short distances, specialized scenarios, coral sand beaches and tropical lagoons. The Rhine was different: 40-degree water, industrial current speeds, enemy artillery zeroed on every crossing point. And it was 1945. The DUKW design was already 3 years old, considered yesterday's innovation by planners focused on post-war developments. The cold was the first problem. Pacific DUKWs used standard marine lubricants that turned to molasses in European winter. Rubber seals cracked in sub-freezing temperatures. Engine oil thickened until starter motors couldn't turn crankshafts. Even the canvas tops became brittle, splitting under wind pressure. But cold weather modifications were possible. Arctic-grade lubricants, synthetic rubber gaskets, engine block heaters, additional insulation around critical components. The bigger challenge was doctrinal. How do you integrate amphibious vehicles into European river crossing operations that assumed bridges, ferries, and fixed crossing points? February 1945, a classified shipment arrived at Allied supply depots near the Rhine. 67 DUKWs pulled from Pacific inventory, modified with cold weather lubricants and additional armor plating. The trucks looked ungainly on European roads, too wide for most bridges, too tall for standard garages. Maintenance crews complained about the twin-drive complexity. Drivers trained on conventional vehicles struggled with water navigation. The learning curve was steep. DUKWs handled differently than pure trucks or pure boats. On land, they steered like overweight cargo vehicles, wallowing through turns, requiring extra space for parking. In water, they responded slowly to rudder inputs, needed constant throttle adjustment to maintain heading against current. The transition between land and water required precise timing. Too fast into the river and you'd flood the engine compartment. Too slow and you'd get stuck on the bank. Training accidents were inevitable. A DUKW attempting its first Rhine entry got hung up on the muddy bank, engine racing uselessly as wheels spun and propeller churned air. Another stalled mid-river when the driver forgot to engage the propeller clutch, drifting downstream until a recovery boat could intervene. A third suffered transmission failure when the operator tried to shift from water drive to land drive while still partially submerged. The drivers learned to read water like experienced riverboat pilots. Rhine currents varied by season and weather. Industrial runoff created unpredictable eddies. Debris from upstream bombing raids, damaged bridge sections, unexploded ordnance drifted downstream at random intervals. Navigation required constant throttle adjustment, course correction for current, obstacle avoidance under blackout conditions. But night tests revealed the game-changing advantage. February 28th, 2:30 a.m. A single DUKW entered the Rhine in a middle Rhine sector, invisible to German observation posts. Water temperature, 38 degrees Fahrenheit. Current speed, 6 mid-peak. The truck-boat hybrid maintained MEM3 mid-PT's forward progress, carrying a full load of ammunition boxes. Navigation time, 8 minutes to cross 400 meters of river. No bridges built, no ferries exposed, no construction signature that German artillery could target. The sound was wrong for German ears accustomed to river traffic. Not the rhythmic splash of oars, not the steady chug of diesel engines, not the mechanical grinding of ferry cables. Instead, a different frequency. Propeller wash mixed with tire noise on gravel, transmission whine transitioning between gear ratios, the peculiar harmonic of water flowing around wheels that were never designed to be submerged. The DUKW emerged on the eastern bank, shifted into road gear, and drove inland like it had never touched water. Wet tire tracks on German soil, but no boat had landed, no bridge had been built, no ferry had crossed. The evidence violated basic assumptions about how armies moved across rivers, but the numbers get worse for the defenders. Coming up, the hourly tonnage that turned a fortress into a supply lane. March 1st brought the first major problem. A DUKW loaded with radio equipment suffered engine failure mid-river. The vehicle's dual-purpose design became a liability, too heavy to paddle, too unwieldy to tow quickly. German patrols along the eastern bank began investigating unusual activity. For 47 minutes, the disabled DUKW drifted downstream in 38-degree water. The crew faced impossible choices: abandon classified communication equipment, risk exposure attempting repairs in full view of German positions, try restarting the engine, and possibly flood the electrical systems. Every minute in that freezing current dropped their core body heat. Manual propulsion was impossible. 13,000 pounds of loaded DUKW, far beyond human paddling capability. German searchlights swept the water. Radio chatter increased along the eastern bank. The disabled vehicle drifted toward German-controlled territory with each passing minute. Coming up, the moment that almost exposed the entire operation. Pause everything. What happens if your engine dies mid-river at 38 degrees? The crew tried everything. Emergency hand crank starter. Engine turned but wouldn't catch. Fuel line check. No obvious blockage. Electrical systems functioning, but engine ignition failed. Water temperature gauge showed overheating despite the freezing Rhine water. The propeller had stopped turning. They were now a 13,000-pound piece of classified equipment drifting toward enemy territory. Recovery teams scrambled from the western bank. A second DUKW launched immediately, followed by a conventional patrol boat. Radio silence protocols were abandoned. Operational security became secondary to crew survival and equipment recovery. German observation posts noted increased Allied activity along the riverbank. Searchlights probed the water more systematically. At 3:17 a.m., the recovery DUKW reached the disabled vehicle. Towing procedures had been practiced, but never under combat conditions with potential enemy observation. The tow line connected successfully. Both vehicles now moved as one unit. Double the target profile, half the maneuverability, completely vulnerable to German artillery if discovered. Recovery succeeded, but the incident highlighted a critical vulnerability. DUKWs performed brilliantly under normal conditions, but any mechanical failure in mid-river created massive operational security risks. Standard contingency plans, abandon equipment, swim to safety, weren't viable with 2.5-ton vehicles carrying classified cargo. Engineers developed new protocols immediately. DUKWs would cross in pairs, each capable of towing the other. Emergency flotation gear would be standard equipment. Most importantly, crossing times would be limited to moonless nights when German observation was minimal. Backup communication plans would account for radio silence requirements during recovery operations. But March weather had other plans. The numbers tell a brutal story: artillery doctrine versus mobile crossing math. March 15th brought heavy cloud cover, perfect concealment for large-scale testing. 23 DUKWs crossed simultaneously, carrying everything from mortar rounds to medical supplies. The operation validated logistics planners' most optimistic projections. Sustained supply rates exceeded conventional bridging by 300%, with zero vulnerability to artillery targeting. The sight was unprecedented in military history, vehicles driving directly into fast-moving water, maintaining formation, navigating by compass heading while propellers pushed against industrial current. Each DUKW carried 5,000 pounds of cargo: ammunition crates, fuel jerrycans, medical supplies, communication equipment. Loading procedures were refined to military efficiency, back up to supply dumps like conventional trucks. Drop tailgates, load cargo, drive directly into the river. No splash of landing craft hitting beaches, no grinding of pontoon bridge sections being positioned, no vulnerable construction crews working under enemy observation. Just trucks treating a major European river like a muddy farm road. The sensory details told the story of innovation under pressure. Engine noise shifting from road rumble to water thrust as propellers engaged. Diesel exhaust mixing with river mist. Canvas cargo covers flapping in downstream wind. Radio static crackling with position reports. DUK7 crossing grid 347891. Cargo medical supplies. ETA Eastern Bank in 8 minutes. Then the clouds cleared. What do you call a truck that thinks it's a boat? The Germans were about to find out. A German observation post near Mainz caught sight of what appeared to be trucks driving across the Rhine. The initial report was dismissed as combat fatigue, poor visibility, possible hallucination. Trucks don't float. Water doesn't support wheeled vehicles. Basic physics made such observations impossible, but multiple posts reported similar sightings. The observer reports were consistent enough to create problems for German intelligence. Post 47 Delta reported vehicles crossing without visible support. Post 52 Gamma described truck-like objects maintaining course against current. Post 61 Alpha documented wheeled vehicles emerging from water onto Eastern Bank. File this under impossible. Trucks on water, under fire, at night. March 18th, Wehrmacht intelligence compiled witness statements from 17 different observation positions. The reports were consistent. American vehicles were crossing the Rhine without bridges. without ferries, without any visible support infrastructure. The vehicles appeared to drive directly into the water, continue across the current, and emerge on the German side fully operational. German engineering officers reviewed Allied technical intelligence, searching for explanations. Temporary pontoon bridges that could be quickly submerged, no evidence of construction, underwater tunnels, survey data ruled out the possibility, experimental hovercraft, no matching technology in captured Allied documents, intelligence files contained scattered references to amphibious trucks from Pacific Theater reports. But those vehicles were associated with beach landings, not river crossing operations. The idea that cargo trucks could navigate major European waterways seemed beyond Allied technical capability, or at least beyond practical military application. The conclusion was unsettling. Either German observers were experiencing mass hallucinations, or the Americans had developed amphibious vehicles that Wehrmacht planners had never encountered. How do you target something that shouldn't exist? March 19th brought German artillery probing fires across likely crossing points. Conventional doctrine called for interdicting bridge construction, suppressing ferry operations, creating kill zones at known ford locations. But if the enemy could cross anywhere, traditional targeting became problematic. Artillery officers requested clarification. Where should defensive fires be concentrated if crossing points were mobile? How could they establish kill zones against vehicles that appeared to be both trucks and boats? What was the engagement protocol for targets that violated basic assumptions about military transportation? March 20th, German defensive plans received urgent revision. If Allied vehicles could cross rivers independently, traditional choke point strategies became obsolete. Artillery targeting protocols assumed fixed crossing points, bridges, ferries, known ford locations. Mobile crossing points meant defensive fire would be dispersed, reactive, always one step behind enemy movement. For the first time since 1940, German river defense doctrine acknowledged that water barriers might not be barriers at all. The implications extended beyond the Rhine. If Americans possessed trucks capable of river crossing, what about smaller waterways? What about canals? What about flooded areas that had been considered impassable to wheeled vehicles? German defensive planning throughout Western Europe relied on natural obstacles to channel enemy movement into predictable kill zones. If those obstacles could be bypassed by common-looking cargo trucks, then defensive mathematics required complete recalculation. March 23rd, Operation Plunder commenced. British, Canadian, and American forces launched the largest river crossing since D-Day. Conventional assault boats carried initial waves across the Rhine, while smoke screens concealed follow-on operations. German artillery responded exactly as expected, targeting visible bridging sites, attempting to interdict known crossing points. But the real logistics operation was invisible. While German guns focused on obvious targets, 67 DUKWs began continuous supply runs. Each truck boat carried 5,000 pounds of cargo: ammunition, fuel, medical supplies, communication equipment, replacement parts. Transit time: 10 minutes from Western Bank to Eastern Bank. Loading time: 5 minutes. Return trip: 8 minutes with wounded soldiers or captured intelligence. The loading procedures had been refined through weeks of practice. DUKWs backed up to supply dumps like conventional trucks. Tailgates dropped, cargo loaded with standard military efficiency. Then they drove directly into the river without pause, without ceremony, without any indication that they were about to attempt something that German doctrine considered impossible. Ammunition crates, fuel jerry cans, medical supplies, radio equipment, all cargo that traditionally required complex transfer procedures, from land transport to watercraft, then back to land transport on the far side. DUKWs eliminated the entire middle phase, land vehicle to land vehicle, with water simply becoming another type of terrain to traverse. The math was devastating to German defense calculations. Question for you: would you crew a bridge team under artillery or a DUK crossing in the dark. Each DUKW averaged 2.5 to 3 round trips per hour under operational conditions. 67 vehicles meant approximately 170 to 200 crossings per hour, moving 425 to 500 tons of cargo hourly, sustained around the clock under smoke cover and night rotation. No bridges to target, no ferries to sink, no construction crews to suppress with artillery. The comparison to conventional crossing operations was stark. Standard pontoon bridge construction across a 400-meter river required 18 to 24 hours under combat conditions, assuming continuous work by engineer companies and minimal enemy interference. Bridge capacity typically maxed out at 300-400 tons per hour, with entire operations vulnerable to single artillery strikes on critical span sections. DUKW operations achieved comparable tonnage within hours of initial assault, with distributed vulnerability that made interdiction nearly impossible. Destroying one vehicle eliminated 2.5 tons of capacity. Destroying one bridge span eliminated entire crossing capability. Quick reality check: bridges attract shells, ducks attract confusion. The psychological impact was as significant as the logistics advantage. German defenders had prepared for conventional river assault. Waves of infantry boats, engineers struggling to position bridge sections under fire, vulnerable supply ferries operating on predictable schedules. They could engage those targets with established fire control procedures. But how do you target a truck that drives into the water, crosses like a boat, then drives away like it never got wet? Artillery doctrine assumed that crossing points would be visible, predictable, sustained. Forward observers could call fires on bridge construction sites, ferry landing areas, supply transfer points. Defensive fires could be pre-registered on likely crossing locations. Kill zones could be established and maintained. DUKWs made traditional targeting impossible. Crossing points were wherever vehicles entered the water. Supply transfer occurred continuously during transit, not at fixed locations. Vehicle density was too low for area weapons, too dispersed for precision targeting, too mobile for sustained engagement. German radio intercepts captured the confusion. Intercept report, paraphrased from listening posts: Lastwagen auf dem Wasser. Bestätigung, vehicles and artillery pieces crossing without visible bridges. Repeat, American trucks crossing without bridging visible. A second intercept, March 24th, 03:47 hours. Request immediate air reconnaissance. Ground observers report motorized equipment crossing river independently. Repeat, wheeled vehicles operating on water without visible support. Engineering assessment requested. A third transmission, 0412 hours. Negative on bridge construction at grid 337883. Negative on ferry operations at 351897. Confirm vehicle crossing reports from Post Delta through hotel. Unable to identify support infrastructure. Request priority intelligence assessment. Intelligence assessment proved difficult. Allied technical documents captured earlier in the war contain no references to amphibious truck operations in European theatre. Pacific Theatre intelligence mentioned amphibious vehicles, but associated them with beach assault operations, not river crossing logistics. But air reconnaissance confirmed what ground observers reported. American vehicles were indeed crossing the Rhine independently, maintaining tactical mobility while carrying strategic supplies. The sight violated every assumption about river warfare that Wehrmacht doctrine had refined since 1914. Luftwaffe reconnaissance photos showed Allied trucks lined up on the western bank, then the same vehicles emerging from water onto the eastern bank, with no visible bridging equipment or ferry operations. The photographic evidence matched observer reports, but the technical explanation remained elusive. By midnight, March 24th, DUKW operations had established 3 independent supply corridors across the Rhine. German counterattacks found themselves hitting targets that could relocate faster than artillery could adjust fire. Forward positions that should have been isolated by river barriers were receiving continuous resupply. Wounded Allied soldiers were being evacuated directly to Western Bank hospitals without exposing vulnerable stretcher bearers to cross-river transport. The tactical implications extended beyond immediate operations. German defensive planning throughout the war had assumed that river barriers would limit Allied supply capacity, creating windows of vulnerability that counterattacks could exploit. If supply capacity was unlimited, if evacuation was continuous, if logistics operations were invulnerable to interdiction, then river defense doctrine required fundamental revision. Watch this flip, when water stops being a barrier and becomes a road. German defensive planning throughout the war had relied on natural barriers, rivers, mountains, urban choke points, to multiply defensive effectiveness. If barriers could be bypassed by common-looking trucks, then defensive mathematics required complete recalculation. Static positions became liabilities. Fixed fortifications became targets rather than assets. River defense doctrine assumed that crossing operations would be visible, predictable, vulnerable. Engineers would need days to position bridge equipment. Construction crews would be exposed to artillery fire. Supply operations would be limited to narrow corridors that German guns could interdict. DUKWs eliminated every assumption. No construction phase, no vulnerable crossing points, no predictable supply corridors, just trucks that happened to float, carrying strategic tonnage across water barriers that centuries of military engineering had considered absolute. The technological impact was as significant as the tactical advantage. German engineering had focused on creating better river obstacles, stronger bridge demolitions, more effective ferry interdiction, improved underwater barriers. Allied engineering had focused on bypassing river obstacles entirely, vehicles that treated water as navigable terrain. Wehrmacht engineering reports from late March 1945 recommended doctrine revision and accelerated withdrawal from river-line defenses. If the enemy possessed vehicles that treated water as terrain, then traditional geographic advantages required reassessment. Better to trade space for time, avoid predictable positions, force the Allies to extend supply lines over land rather than concentrating defensive fire on water crossings that might not exist. The DUKW had started as a solution to Pacific Island logistics. It ended as the vehicle that made German river defenses strategically irrelevant. April 1945, German forces accelerated withdrawal from river positions along multiple waterways, with revised doctrine citing concerns about Allied amphibious capabilities. Intelligence reports indicated that American amphibious trucks could potentially bypass water barriers, making traditional riverline defense less predictable. Better to preserve forces for mobile defense in depth. The broader implications reached beyond immediate tactical concerns. If American industry could produce trucks that operated on water, what other assumptions about enemy capability were obsolete? What other traditional defensive advantages might be neutralized by Allied technological innovation? German military planning had always emphasized thorough analysis of enemy capabilities, but DUKW operations revealed a blind spot in intelligence assessment. The vehicles had been operating in the Pacific for 3 years, but European theater planners hadn't considered their application to river crossing operations. Theater separation had created intelligence compartments that limited cross-theater learning. Pacific innovations weren't automatically shared with European commands. European tactics weren't necessarily adapted for Pacific conditions. The DUKW represented successful technology transfer between theaters, but German intelligence hadn't anticipated the adaptation. One more twist. Invisible logistics beat visible heroics. The irony was mathematical. Germany possessed some of the world's most advanced military engineering, sophisticated artillery doctrine, and experienced defensive tactics. But those advantages assumed that rivers would remain rivers, that water would stop wheeled vehicles, that basic physics would favor defenders. The DUKW simply ignored the assumptions that centuries of military science had accepted as permanent. European military tradition viewed rivers as natural fortifications, obstacles that channeled enemy movement and created defensive opportunities. The Rhine, the Danube, the Elbe, these waterways had shaped military campaigns since Roman times, forcing armies to concentrate at crossing points where defenders could mass fires and launch counterattacks. Military engineering had refined river defense concepts for generations, fortified crossing points, prepared demolitions, interlocking fields of fire. Defensive doctrine assumed that attacking forces would be constrained by geography, forced into predictable approach routes, vulnerable during crossing operations. American industrial pragmatism approached the same problem differently. Instead of accepting rivers as obstacles, why not build vehicles that treated water as navigable terrain? Instead of fighting geography, why not engineer around it? The solution wasn't elegant or sophisticated. DUKWs were ungainly, mechanically complex, vulnerable to breakdown. They required specialized maintenance, dedicated training, careful operational planning. From an engineering perspective, they represented compromise and improvisation rather than breakthrough innovation. But they worked. That was the American criterion. Not perfection, not elegance, not optimization, but effectiveness under operational conditions. DUKWs solved the river crossing problem by ignoring conventional solutions and creating new possibilities. The industrial capacity required for DUKW production was uniquely American. General Motors had retooled civilian truck production lines to manufacture amphibious vehicles, combining automotive assembly techniques with marine engineering requirements. The hybrid approach, neither pure truck nor pure boat, reflected American manufacturing flexibility and willingness to experiment with unconventional solutions. German industry, despite its technical sophistication, struggled with such adaptability. Specialized equipment required dedicated production facilities. Design changes meant lengthy retooling processes. Innovation proceeded through careful engineering analysis rather than rapid prototyping and field testing. The DUKW development cycle exemplified American industrial culture, concept to prototype in months rather than years, field testing under combat conditions rather than extensive laboratory analysis, production decisions based on operational feedback rather than theoretical optimization. War correspondents later described the Rhine crossing as a triumph of Allied engineering and logistics. They focused on bridge construction, artillery coordination, and infantry heroism. But the decisive factor was uglier, more prosaic, and less photogenic. Surplus trucks from the Pacific that happened to float. The media narrative emphasized conventional military virtues: courage, sacrifice, technical excellence. The DUKW story was less dramatic but more significant: industrial improvisation, technological adaptation, logistical innovation. Americans had solved a military problem by treating it as an engineering challenge rather than a tactical obstacle. Combat correspondents struggled to explain DUKW operations to audiences accustomed to conventional warfare narratives. How do you describe trucks that drive across water? How do you convey the strategic significance of vehicles that look ordinary but perform extraordinary missions? The visual contradiction was part of the DUKW's effectiveness. German observers expected amphibious vehicles to look exotic, specialized, obviously different from standard equipment. DUKWs looked like trucks until they entered the water. The camouflage was technological rather than visual, hiding capability rather than appearance. Photojournalists captured images of DUKWs emerging from the Rhine, water streaming from wheel wells, cargo still secure in truck beds. The photographs showed what appeared to be impossible: wheeled vehicles operating in aquatic environments without visible means of flotation or propulsion. But newspaper editors faced challenges explaining the images to civilian audiences. Technical descriptions of dual-drive systems and amphibious modifications were too complex for general readership. Simple explanations, trucks that float, seemed inadequate for vehicles that had revolutionized river crossing operations. The same vehicles that had carried wounded Marines across coral lagoons now carried German defensive doctrine into obsolescence. Water barriers that had protected European armies since Roman times became highways for American logistics. The river that had defined German defensive planning became just another road. Post-war analysis would reveal the full scope of DUKW impact on the Rhine crossing. Traditional bridging operations typically required 96 hours to establish sustainable supply flow across a major river under combat conditions. DUKW operations achieved sustainable supply flow within 12 hours of initial assault, with zero vulnerability to artillery interdiction of crossing points. The time differential was strategically decisive. German defensive doctrine relied on counter-attacking bridgeheads before they could be reinforced and supplied. 72-hour windows provided multiple opportunities for coordinated counter-assaults. 12-hour windows compressed response time beyond effective reaction capability. Supply tonnage comparisons were equally significant. Conventional bridge operations peaked at 400-500 tons per hour under optimal conditions. Clear weather, minimal enemy interference, uninterrupted construction. DUKW operations sustained 425-500 tons per hour under combat conditions. Enemy fire, variable weather, continuous operations, but tonnage figures understated DUKW advantages. Bridge operations required massive infrastructure investment, engineering units, construction materials, protective forces, maintenance capabilities. DUKW operations required only vehicles, fuel, and drivers. The resource efficiency was unprecedented in river crossing history. Vulnerability analysis revealed the most significant difference. Single artillery strikes could disable entire bridge operations by targeting critical span sections or support structures. DUKW operations distributed vulnerability across individual vehicles. Losing one DUKW eliminated 2.5 tons of capacity while preserving system functionality. The cost differential was equally significant. Bridge construction required specialized engineering units, massive quantities of structural materials, and continuous defensive commitment to protect vulnerable crossing sites. DUKWs required only standard truck maintenance and fuel, with operational security provided by mobility rather than fixed defenses. German post-action reports acknowledged that river defense doctrine required fundamental revision in light of Allied amphibious vehicle capabilities. Traditional choke point strategies became obsolete when crossing points could be anywhere along hundreds of kilometers of riverfront. The strategic implications extended beyond immediate tactical considerations. German defensive planning throughout Western Europe had relied on water obstacles to channel Allied advances into predictable corridors where defensive fires could be concentrated. If water obstacles could be bypassed, entire defensive concepts required reconsideration. Intelligence assessments conducted in April 1945 attempted to analyze DUKW capabilities and develop countermeasures. Technical intelligence sought to understand vehicle specifications, operational limitations, vulnerability factors. Tactical intelligence analyzed employment methods, logistics requirements, maintenance needs. But the intelligence effort came too late to affect Rhine operations. By April 1945, Allied forces were advancing beyond river barriers into the heart of Germany. DUKW operations had achieved their strategic objective, making the Rhine crossing a logistics exercise rather than a combat obstacle. The technological surprise had been complete. German forces had no effective countermeasures against amphibious vehicles that operated like trucks on land and boats on water. Artillery doctrine assumed fixed targets. Anti-tank doctrine assumed land-based vehicles. Anti-naval doctrine assumed water-based vessels. DUKWs fell between doctrinal categories, vulnerable to weapon systems designed for different target types, but not optimally engaged by any single countermeasure. The hybrid nature that made them versatile also made them difficult to counter using conventional weapons and tactics. Post-war German engineering analysis concluded that effective countermeasures would have required dedicated anti-amphibious weapons and tactics that hadn't existed in 1945. Developing such capabilities would have diverted resources from other priorities and addressed a threat that hadn't been anticipated. The Rhine still flows 400 meters wide, still moves at 6 miles per hour, still drops to near freezing temperatures in March. But it never again stopped an army that possessed trucks capable of turning water into a highway. The barrier that had seemed an impenetrable fortress became a supply route, and Germany's last natural defense became just another problem solved by American industrial improvisation. The legacy of DUKW operations extended beyond World War II to influence post-war military doctrine and equipment development. Amphibious capability became a standard requirement for military vehicles operating in environments with water obstacles. River crossing operations incorporated amphibious vehicles as standard equipment rather than specialized assets. Modern military forces take amphibious capability for granted, but the concept was revolutionary in 1945. The idea that trucks could navigate rivers, that logistics vehicles could operate in multiple environments, that single platforms could eliminate transfer requirements. These concepts transformed military transportation and logistics doctrine. The DUKW represented a moment when technological innovation overturned centuries of military assumptions. Water barriers that had channeled armies since ancient times became navigable highways. Geographic advantages that had defined European warfare became irrelevant obstacles. The river that had protected Germany's industrial heartland became just another road. And in that transformation, the nature of modern warfare revealed itself, not as a contest between traditional military virtues, but as a struggle between competing approaches to technological innovation and industrial adaptation. The side that could engineer around problems rather than fighting through them held decisive advantages that no amount of courage, skill, or tactical excellence could overcome. The Rhine crossing succeeded because American industry had created vehicles that German doctrine hadn't imagined. It was that simple and that revolutionary.